All right, so we're going to spend the next few sections here, or next few parts, learning how to draw Lewis structures, right, for our covalent compounds. And this is really important because by looking at a formula, we should be able to, in our mind, picture what a molecule looks like. And if we can picture what a molecule looks like, we can help predict its properties and its reactivity, right? That's what science is all about. Learning some stuff and then being able to use that to make predictions for the future. And then, of course, testing those predictions with experimentation and then building on itself to build the collective knowledge of humanity. So drawing Lewis structure, right, I would consider this the most important Gen Chem skill. And it's really a lot of practice. You can watch a lot of videos on it, but really you want to get in there, get your hands dirty, and then figure it out. There's a lot of little nuances to it, a lot of little steps and procedures. So what we're going to do is we're going to try to break it down and follow a step-by-step procedure. That will work, 99% of that time. And then that you have to learn that extra 1% with different exceptions and stuff like that. So the first step for drawing our Lewis structures is to look at our compound, and we want to count our valence electrons. So let's take a look at some examples. So here we'll do CO2, and then here we'll do CH3OH. So remember, the number of valence electrons is dependent on the group that it's in. So for example, here we've got carbon. Carbon is over here in group 4, so it's going to have 4 valence electrons. We've also got oxygen. Oxygen is in group 6, so it's going to have 6 valence electrons. And then we've got hydrogen, that's in group 1, so it's going to have 1 valence electron. So you need to be really comfortable with seeing how many valence electrons each element has, depending on the periodic table, right? That's a skill that we've practiced, and now we're going to put it into place. And so what we're going to do is just going to add up our valence electrons. So carbon has 4 of them, oxygen has 6, but then there are 2 oxygens, right? There's 2 oxygens, so we have to multiply that 6 by 2. We sum that all up, we get 16 valence electrons. Down here, we've got a carbon that's got 4 valence electrons. We've got 1 oxygen that's got 6 valence electrons. And then we've got a hydrogen. Each one has 1 valence electron. But if you think about it, there's 4 total, right? H3 plus another H is 4. So then we just go ahead and do the math, and we get 14 valence electrons. So when it comes to covalent compounds, right, these are both neutral overall, right? You see no charge there, but sometimes there is a charge. So for example, we can have a compound NH4+, that's ammonium. We'll learn the nomenclature later, but right, you see that has a positive charge. Or something like nitrate, this is NO3-. So you see they have charges. And whenever we have charges, that means that we either have some extra or some missing electrons. So whenever you see a negative charge, we want to add an extra electron, right? Because an electron is negative. So if you have a negative charge, that means you have an extra electron. And if you have a -2 charge, you have 2 extra electrons. And then vice versa, if you have positive charge, that means that you lost an electron. So we want to subtract out an electron. So let's go ahead and take a look at what that looks like. So nitrogen, according to the periodic table, has 5 valence electrons. Hydrogen each has 1 valence electrons, and then there's 4 of them. And then because we have that positive charge, we want to subtract out 1 electron. And so when we do the math there, we end up with 8 valence electrons. Down here, right, nitrogen has 5 valence electrons. Each oxygen will have 6 valence electrons, but in this case, we have 3 of them. And then we have a negative charge, which means that we have an extra electron. So we need to add 1 more electron there. Sum those all up, and you should get 24 valence electrons, right? So that's the step 1, counting the valence electrons. Shouldn't be too difficult, and you want to get pretty good at it.